Welcome to Math Mini Lessons. This is our special review video for our 8th graders taking the New York State exam. I'm going to go over the different problems. What I'm going to ask you to do is I'm going to leave a link in the video description. I will show you where to find a copy of this exam. This is last year's exam, and some questions have been taken out. So some questions are released, some questions are taken out. So here is some information about this test and how to use this study video to do your best on next week's state test. I can tell you that this test design for this year, for 2023, there are 2 days. The first day is all multiple choice, so it's multiple choice and nothing else. So 32 multiple choice questions. There will not be 32 multiple choice questions on this exam because some questions have been taken out. On day 2, you have a range between multiple choice questions. You get 6 of them. And this year, you're going to get 3 1-point questions. They're probably going to be computations, 6 2-point questions, and 1 3-point question. So altogether, you're going to have 48 problems over those 2 days. In 8th grade, you're going to be able to use your calculator, but regardless, make sure all your thinking is on the page, even if you're using a tool. This is the blueprint of the exam, meaning how they kind of come up with the questions and the ranges. And just by looking at it, you can see there are 5 different types of questions. You've seen them all year in school. The biggest sets will come from these 3 parts. From EE or algebra ones, expressions, equations, and inequalities. That's going to be a very big section this year, 28 to 41%, as well as geometry will be another large section, 28 to 41%. So these 2 alone will be about half of your test. Then you're also going to have function questions that can be anywhere between 16 and 25% of the test. So just between these 3, that's a bulk of your test. Some of your test is going to have some EE skills. Very little will be number sense, and very little will be stats and probability. But these will be your big bulks. So as I'm going through the questions today, a lot of them are going to have EE, function, and geometry. So what I'd like you to try and do is take the test for yourself. Your home is just practice, it's a simulation. Take the time you need and try out the questions. If you feel super confident after you've done the problem, I usually put a check when I'm confident, and I put a question when I'm just not sure. And those are the ones that, as you're going through the video, you want to see what the answer is to validate, like see were you on the right track? Was there something really different? So you want to check for that. And especially check if you're skipping a problem. Like if there was something you skipped and you weren't sure, you had no idea, definitely watch those questions. But as I'm going through, I'm going to show you what the right answer is first. If you have the right answer, keep moving. Just fast forward the video to the next page. But if you found that something was wrong, stay there and just take some time to look and watch my work and compare it to yours and figure out what's different. Is it in the approach? Is there a misconception? Is there a computation error? Try to figure out where the mistake is and ask questions. Those are the types of questions you want to practice the most. And I'm also telling you what kind of question it is. So if you're noticing that you're getting a lot of geometry questions wrong, then spend some time this weekend reviewing geometry, and on Monday in school, ask adults, teachers, friends to do more practice with geometry. This is where you can identify where you need a little bit more support and more practice. It is fine if you don't know it automatically, but it's not okay to just sit there and just say, you know what, I don't want to learn this. I'm never going to get it. Ask the question for the things that you're not confident in and see if someone can explain it to you in a different way. I also invite you guys, as I always do with any Math Marble, if you're new to the channel, you can always do this. Put questions in the comments. I have people who email me all the time, ask me questions. Can you make a video about this? Can you give me something about that? Can you find a way to explain this? If I have a video, I'll link it. And there are some people where I just make a video on the spot so that someone has a quick way to learn or to think about a topic. So I'm always happy to do that for Math Marbles. All right, and if you have a different strategy you want to share, because there's always more than one way, share it so that other people can benefit as well. So with that, You have your task. I hope you get some good use out of today's practice and you feel a little bit more confident for next week's exam. Here's our first question. It's a function question, and 83% of students last year in New York got this question correct in 8th grade. Which graph represents a function that is increasing? Okay, so what I'm looking for is I'm going to look at the slopes and identify where we see an increase. In the first one, there is no change, so there's no slope. In B, it is undefined. Why? Because I can see a lot of change in Y, but no change in X. So change in Y over change in X, and we can't divide a number by 0, so we call this one completely undefined. In C, it's decreasing, and D is the only one that shows an increase in slope, and it also passes our vertical line test. I could make a vertical line and it would only hit in one place. Let's go to the next one. What is the solution to the equation shown below? So here's the answers for 2 and for 3. They're both A. If you got them correct, keep going. If not, let's go over them. All right, so looking at 2, I'm going to start by rewriting the equation. I'm going to give myself some space. I'm going to start by distributing. And I do have my calculator here that we can also continually use, and you'll have access to as well. Our goal here is to isolate the x to one side. So I'm going to create a 0 pair. Leave me with just 12 and 5/10. And to retain balance, I do the same operation to the other side. So I get 5.0x. I'm actually just going to write 5x minus 0.5. And I'm going to create another 0 pair here. So now I have 13 is equal to 5x. And divide both sides by 5 so I can isolate my x. 13 divided by 5 on my calculator is equal to 2.6. I'm going to box this. And you can see why this matches our answer. X is equal to 2 and 6/10. I'll go to the next one. This one is a geometry problem. There are 2 boxes of cereal. We're creating a rectangular prism. Box A has dimensions 25 by 20 by 9. Box B, 25 by 19 by 6. And we want to know what is the difference in volume between the 2 boxes. So I'm going to find the volume for each separately. Here's A, here's B. And let's plug in our dimensions. So for A, it is 25 times 20 times 9. And for B, it is 25 times 19 times 6. We'll simplify the first one. So 25 times 20 times 9, the volume is 4,500 centimeters cubed. And for our second box, 25 times 19 times 6, I get 2,850 centimeters cubed. And I want the difference between them, so I'm going to do volume of A minus volume B. So 4,500 minus 2,850. And I get 1,650 centimeters cubed. And there's my answer, so you can see it there. All right, jot either of these down. If you had an error, try and find out where that error was and just identify it for yourself. So that's the goal of this. If you find that you have an error, your job is to try to figure out where the mistake happened so you can build that self-awareness. Let's go to the next one. Here's our answer for number 4. It's an EE problem. You should get D. So let's work out how you can find it. We have an equation. We're going to write them in y-intercept form. So that's the same as y equals mx plus b. The m represents our slope, and our b is the coordinate in the y-intercept. So we're going to look for the y-intercept, wherever that y is, that's going to be our b. So I can identify the b pretty easily because I'm going to look for my y-intercept is right here. And that's at 0.04. So our b is equal to 4. Let's figure out what our m is. And all I'm going to do is I'm going to take these 2 points and I'm going to create a triangle. I'm going to figure out the change in y over the change in x. And I notice it's going up to this point and then over here. And so I'm just going to figure that out. It goes from -6 up to 4, so it's going up 10, and it's going over 4. If you're not sure how I did that, literally just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4. So my slope is, it went up 10, so positive 10 over 4. So y is equal to 10 over 4 x plus 4. I could actually simplify that 10 over 4, so let's do that. So y is equal to 5 over 2x plus 4, and that's the same answer as D. Here are the answers for 5 and 6. We have an EE question and a geometry question. We'll start with the geometry question. We want to figure out, we have 2 lines intersecting. If y is equal to 115 degrees, what is the value of x? So first thing to note, these 2 angles are vertical angles. And they're congruent to each other. They're equal to each other. So y is equal to 2x minus 15. We've already been given the value for y. So it's saying if y is 115, so I'm going to substitute 115 is equal to 2x minus 15. We're going to solve for x. So again, I'm creating a 0 pair, leaving me with 2x. And I'm keeping balance to the other equation. And I get 130 is equal to 2x. We're going to isolate the variable by dividing by 2. 2 divided by 2 is just 1. It leaves me with 1x. And 130 divided by 2 is 65. Let's look at the next one. Triangle P undergoes a series of transformations resulting in triangle Q. Which sequence of transformations could be used to show that triangle Q is similar but not congruent? So similar tells me same shape, different size. Of these transformations, which of these will keep the shape but change the size? So a translation is just a slide. Excuse me. And a slide doesn't change the size of it. So it's going to stay congruent. So I can eliminate that. A reflection is just a flip. And it's still going to be congruent. Doesn't change, just looks like a reflection. A rotation, I'm just turning it. I'm turning it on its origin. So it's still going to be congruent. But a dilation, that's a shrink or a stretch. It's going to look the same. It's kind of like when you reduce something where you change it on your phone where you zoom in, zoom out. That's a dilation. And that one is going to change the size, but it's going to be the same shape. So it's just like on your phone when you zoom in and you zoom out, Same picture, it's just bigger or smaller. Here's 7 and 8. We have an SP. Well, this one is actually statistics, and then an EE. So we'll start with the first one. So we're going to look at a scatter plot, which is just a whole bunch of different points. Which statement best explains why the data can or cannot be modeled using a line of best fit? So looking at the trends, I noticed that in the beginning part, it kind of looks linear, but then it does something funky where most of my points start to trend out this way. So it doesn't have a linear pattern. So given that, I know that I can eliminate C and D because it says a line would be appropriate and a line would be appropriate. I can't create a line that will go through all these points, just a straight line. It would be bent. So I'm stuck between A and B. So A says a line would not be appropriate because there is a negative association. You can have a negative association and still have a line. So that is not true. It just means that many of the points are going to just be down. So that would have been fine. Here I actually have a negative association. So B is the correct answer because it is a non-linear pattern. Let's go down to 8. What is the solution, if any, to the equation 3 times x minus 2 plus 4 is equal to 3x plus 6? Okay, I'm going to zoom in a little bit. Pretend you're not seeing the answer here for a second. First thing I would do is I would start to distribute. So I will get 3x minus 6 plus 4 is equal to 3x plus 6. And I'd start to combine any like terms. And my like terms are right here, these numbers. I can combine them. Negative 6 plus 4 will give me a positive 2. And 3x plus 6. So something I'm already noticing is, and I hope you see it as well, I'm going to have a problem with the 3x's because I have 3x's on both sides. And I know I'm going to have a problem. What I mean by that is, even if I move this 2, I'll move my 2 here. When I have to move my x's to the other side, I'm going to have a problem. My x's are going to be eliminated. So I'm going to end up with 0 is equal to 4, which is not a true statement. So this tells me there is no solution. When you're looking at a lot of these problems, you're going to find x is equal to something if there's a solution at a particular point, but if there is not a point, then such as here, there's no solution to this system of equations. This is not a true statement. Okay, here are answers for 14, 15, and 16. Notice that some questions are going to skip because they were not all released by the state. So check your answers. If you need to go over any of these parts, stay here. If not, keep going. We'll start the first one, which is an EE problem, has to do with exponent rules. So before I can multiply these, I want to do something about this negative exponent. So I'm going to rewrite it using the negative exponent rule. So it would be 1 over 15 to the 7th power. And if you're not sure why that rule works, go to the channel. I have videos on negative exponents so you can actually see where that pattern comes from. Now I can multiply these and I get 15 thirds over 15 to the 7th power. So how do I simplify this out? Now this is where I want you to think about this. The powers just tell me what is being repeatedly multiplied. So I know, I am going to tell you, I can look at this and see that this is going to be 1 over 15 to the 4th power. But I want you to see what I'm seeing in my head. So I'm going to expand this out so you can see it expanded. So this would be 15 times 15 times 15 in my numerator. And I need to write 7 of these in my denominator. All right, now if I'm dividing like common parts, so 15 divided by 15 is 1. Here's another 15 divided by 15 is another 1. and 15 divided by 15 is 1. So all I'm left with my numerator is just 1. So I'm left with just 1 in my numerator. And 1, 2, 3, 4. Here's 15 to the 4th power. So again, all I'm left here is 1 because 15 divided by 15 was 1 times 1 times 1. So I just have a 1 for my numerator and 15 to the 4th power over here. The other thing I knew is that I had more on the bottom. So in my head, I already knew the difference between these two was going to be 4. And I would be left with 1. So that's where I get my answer. Let me circle it here. 1 over 15 to the 4th power. Let's look at the second problem, and it has to do with a unit rate. We want to know what is the unit rate and what is the meaning of the unit rate in this problem. Okay, so in 7th grade you did unit rate problems, and these were problems that were written in this form. AX plus B equals C, where A was that unit rate, and here was some variable. Usually it was some type of independent variable like time or something you bought. B was some type of initial cost. I kind of think of it like when I go to an amusement park. I pay money to get in, a charge to get in, and then I just buy a whole bunch of tickets for the same price. So my unit rate is the price per ticket, and the coming in was like that initial cost. And then C is my total depending on all the other parts. Okay? And I'm trying to figure out the relationship between my X and my C at the end. So here's the problem. He's opening up a savings account. He has an initial deposit of $50. All right, that sounds like that B, that $50. And then each month he deposits the same amount of money. So every month he deposits some money. And that's why it's written as 25M. And T is the total amount. So what does the 25M mean? Here's my unit rate. So this is how much money he's depositing every month. And it's always the same amount. It literally says it in the problem. He deposits the same amount of money. So that's where I know he's putting in $25 every month. So if it's for 1 month, it's $25. It's 2 months, there's $50. After 10 months, it's $250. And this doesn't change because that was the money he started out with. But that's how I can figure out the rest. So there you go. 25 is the amount of money each month. I could also see it because it was my coefficient. So that was my clue that it was going to be my unit rate. Let's go to the bottom part. What is the solution to the equation below? All right, so it's just checking our skills. So -1/3 times 6y plus 6 plus 21 is equal to 3y. We're going to distribute first. So -1/3 times 6 is -6/3 y. I'll deal with the fractions in a sec. -1/3 times 6 again is just -6/3 plus 21 equals 3y. Now let's fix those fractions up. -6 over 3 is -2. So -2y minus 2 plus 21 equals 3y. We're going to combine like terms, and I have -2y plus 19. So I just combine these two together. Yeah, plus 19 is equal to 3y. I'm going to create a zero pair here by adding 2y and adding 2y. So now I have 19 is equal to 5y. I want to give you some space. 19 is equal to 5y. And I want to isolate that y by itself, so I'm going to divide it by 5. So 19/5 is equal to y, and there is my answer. 19/5. I'm trying to write as small as possible so you can see all the work. And let's go to the next page. Here's a function problem. I can look at this function between what two values of x? Is it nonlinear and increasing. Okay, so I'm going to split this into sections where the function changes. So over here, I see a change. Here and here. So that's where when x is equal to -3, where x is equal to 1, and when x is equal to 4. So what am I looking for? We know the two look-fors: nonlinear, increasing. So in my first section A, this is absolutely linear and makes a straight line. In my second section, I'm just going to call it B, it's not a line, it's non-linear. I can see the curve. C looks linear, it's a straight line, and D is non-linear. Okay, so we looked for the first part. We found the two ones that are non-linear, which is here and here. These two are non-linear in those two sections. But I also want non-linear and increasing. And so look at the line, and remember it goes from left to right. This one is increasing, it's going up. Whereas this one is decreasing, it's going down. So here's the place where both those things are true, and it is between what two functions of x, when x is -3 and when x is +1. So again, I'm cutting my chart into the little sections, and I'm looking for the conditions that I wanted: nonlinear and increasing. Found it, and it was between those two x values. Let's go to the next one. Here's 25. I have a cone, and we're going to look at the volume for a cone. So you're going to have to go back to your reference sheet, looking up here, and we're going to look for a cone. This is the formula you want: 1/3 times the area of a circle times the height. Let's go back, because I can't take that part out. So volume is equal to 1/3 times area of the circle, so pi r squared, times the height. All right, let's put in the values that we have. So we have the radius is 6, so 1/3 times pi times 6 squared times 11. We'll start simplifying this out. 1/3 times pi times 36 times 11. Let's start fixing that 36 times 11, and that's volume is equal to 396 over 3 times pi. Getting closer. So now I'm going to simplify 396 over 3. Which gives me 132. So far my volume is equal to 132 pi. Now notice it didn't tell me to leave my volume in terms of pi. Matter of fact, it tells me to approximate it. So I'm going to have to figure out the volume for pi. So depending on the type of calculator you have, you can either type in 132 pi, or you can do 132 times 3.14. So I'm going to just show you both so you can see how close they are together. So here's 132, and if I just press the pi button, I get 414.69. And if I did 132 times 3.14, I would also get 414.48. So they're very, very, very close together. And you can see they're both about 415. And there's my closest approximation. Nothing else was even close to that. Even if you went this number and said, hey, it only rounds to 414, that would still be closest to this approximate value. All right, so hit pause and jot this one down, and we'll go to the next problem. All right, here's our question for number 24. Here's our answer, should be A. We're looking at a triangle, and this has to do with the Triangle Inequality theorem. which basically says that if you add up any two sides, they're bigger than the third. So I can do A plus B and it'll be bigger than C if it's a true triangle, or A plus C and it's bigger than B, or B plus C is bigger than A. So that's what we're looking for, where the sum of two sides is greater than the third side. And the only one that shows that is A. All of these have the sums as less than the third side. So that's what makes B, C, and D incorrect. Let's look at number 25, and we're looking for an equation of the line. So again, I want a line that matches y equals mx plus b form. So I'm going to look for two clues on my graph: my slope and my intercept, or my 0b. Okay, the slope is really easy to find. It's right here, 0.8. So we already have the b is 8. Now we just gotta look at my slope. I could already see that it's going down, so it's going to be negative. Let's use our triangle to do the slope. So it's going down and over, and I'm only doing that so I can find 2 points on the line. There was an easy point here and an easy point here. So I'm going down 8 and over 10. So y is equal to negative 8 over 10x. And I can simplify this to, let's simplify it by 2. So negative 4/5 x plus 8. And there you go. So that's all I'm looking for to find the equation for a line, an intercept, and two really clear points. And they even gave it to you on the graph. Just look for those 2 points and you're going to make a triangle. You're going to look for the change in y, the up, down, and then the change in x. That's it. A vertical line and a horizontal line. And that's going to find you your slope. Here's our answer for 26. It's a rate question. It's an EE question. And we have two equations going, one in an equation, one in a graph. And we're looking for which statement is true. Our equation is y equals 36x. That's how much the first mechanic charges, mechanic A. And mechanic B, I'm looking at these points here. Now, notice they gave us this first point, 288. So I'm going to look for the unit rate pretty much when x is 1, what is y? And since I know it starts at 0, 0, I'm just going to look for that point, that second point, and that's 144. How do I know? Because I know this part went up 2 and over 88. So half of that at the same rate would have been up 1 over 44. So my rate here, y is equal to 44x. Okay, see how I did that? I used that unit rate to write this equation. Now I can compare their rates. So mechanic 2 charges $44 an hour. That's what x is per hour. So there's B, 44 per hour. And A charges 36 per hour. So B definitely charges more, so I'm going to get rid of A and C. And how much more does he charge? He charges $8 more an hour. D is just silly, as if you, how would someone just get to 52? That answer doesn't make sense in this case, because I'm looking for the differences between them, and I can see that 44 is $8 more per hour than 36. So that was the end of the first day of the test. It's all multiple choice questions, so we stopped there. Now we're going to look at day 2, which has a mix of multiple choice and short response questions. You can still use your calculator. Notice for the 2023 test there will be 1-point questions as well, but they do start off with multiple choice. So you get your same conversion chart. I have my calculator on the side. So let's get started. Here's 34 and 35, an SP problem and another EE problem with exponents. So we'll start with the first one. Corey drinks from a bottle during a ride. The average amount of water in ounces can be represented by the equation y equals negative 8x plus 32, where y is the amount of water remaining after x hours. Based on the equation, what is the amount of water in ounces that will remain after Corey rides 2.5 hours? Okay, so this is a simple substitution. So y equals negative 8x plus 32, and they're saying what is y when x is equal to 2.5 hours. So I'm just going to sub that in. Negative 8 times 2.5 plus 32. I'm going to change 2.5 to 5 halves plus 32. And now when I multiply, I get negative 40 over 2 plus 32. Okay, easy enough to simplify. Negative 40 divided by 2 is negative 20 plus 32. And negative 20 plus 32 is positive 12. There you go. I didn't even need a calculator for that one. It was just substitute and simplify. Let's look at the next one. It has more exponents, another negative exponent. So 4 to the negative 1/5 times 4 to the 8th. So I'm going to rewrite the negative exponent as 1 over 4 to the 5th times 4 to the 8th. Let's put a 1 under there so we can multiply them. And we get 4 to the 8th over 4 to the 5th. And so what does this simplify out to? Like, you know, things are going to cancel out, and this is going to leave me with 4 to the 3rd. So this is going to be the value, and I'm going to look which one of these has the same value as 4 to the 3rd. That's the goal of these. So you have to actually use your different rules. And each one of these is a different exponent rule. The first one has to do with our quotient rule. So I have 4 negative 2 minus negative 1. And so that's what I'm subtracting that value. And I'm going to get 4 to the first power. So negative 2 plus 1 would just be 4 to the negative 1. That's not the same. Now I have another power rule. So I have 4/3 to the negative first power. Okay. That's not the same. It looks close, but it's not. In the next one, again, I'm going to change this into, here's my base 4, and I have 2 minus negative 1. And again, this becomes an additive inverse. It becomes 2 plus 1, which is the same as 4 to the 3rd. So C works. And then we have our power of powers rule in the third one. And when you multiply them, you're going to get 4 to the negative 3rd. So that's not going to work. So there's my answer, C. It just focuses on, do you know your exponent rules? That's what we're looking for here. Let's go to the next one. I like these. I really like these geometry problems a lot. So we're going to try and figure out what is the value of n. And let's look at these line angles and the different relationships between them. And one of the relationships have to do with supplemental angles. And what we can say, if we were thinking this angle here is the same as this angle over here. 3n plus 16. Okay, and the way I know that, I'm thinking about this line and its position. This one's parallel, so its position, it would be right here. And now what do you notice about these two lines? These two lines are vertical lines, meaning they're congruent. So 5n plus 4 is equal to 3n plus 16. And now we're just going to solve for n. So let's make a zero pair here. 3n plus 12 is equal to 5n. Let's move this n over here, another zero pair. So 2n is equal to 12. Isolate. N is equal to 6. trick to this one was knowing those angles, figuring out where the congruent angles actually are. Some students actually can automatically know that these angles, can recognize that those angles are congruent. For some students who are never quite sure, I asked them to look for these angles first and then use their vertical angles so they recognize all of these angles I put in blue are congruent. And these red ones are also congruent. Alright, so that was geometry. Got 55% of kids got this one correct. Ooh, another geometry one, and we're going to look for a series of transformations that will map. How do I create this new figure? I want to map trapezioid RSTU to NMLK. And so the first thing I kind of noticed in looking at this, at first it looks like it's going to be a reflection. Problem is, it doesn't go exactly, so it's almost a reflection, but then it's tilted. We're going to draw in if it was an exact reflection. These 2 points would be the same distance. And so if it was a true reflection, you would get this shape here. So not only is it a reflection, but then it had to slide over one. So I reflected it, and then I translated it over by 1 unit. And there you go, reflection over the x-axis. Oh, I should have been very clear about that. Over this side, the x-axis, and then a translation of 1 to the left, which you can see. Okay. It makes a lot of sense why D is incorrect, because yes, there is a reflection, but then it says the translation is going up 1, and that's not true. That would have meant each of these points would have been 1 higher. All right, let's look at 43, which is a geometry problem. This one, a lot of students struggled with, only 0.35 points out of 2. And we're going to try and figure out with a transversal, meaning I have a line that cuts through. This line cuts through 2 parallel. It's a nice slice. I need to figure out what x and y is. Okay, so this is similar to what we noticed before, and let's think about our vertical angles. We know that these two are going to be equivalent to each other. And we know that the same line is going to have the same issue over here, where these two would be equal to each other. Okay, so I'm going to use that to start off the first point. So I know 3y plus 28 is going to be equal to x. So I know that. So how can I use that information? 3y plus 28 is equal to x. Well, I also know that there's another relationship happening here, which is basically that if I know all of these are the same, I'm going to put x here. I also know there's a supplemental relationship that these two angles would equal 180 degrees. So that one is interesting as well. Okay, so which of these is more helpful? X plus y is equal to 180 degrees, or 3y plus 28 plus y is equal to 180 degrees. I think the second one. I could do way more with that second one. So let's erase the first. Let's give ourselves some room. 3y plus 28 plus y is equal to 180 degrees. So I can see there are supplemental angles to each other. So that's why it's great to identify all the congruent angles. And now I can combine. So 4y plus 28 is equal to 180 degrees. Let's subtract 28. 4y is equal to 152. I'm going to use my calculator just to triple check my answers. So 180, yep, 152, and now I'll do the solve for y. Y is equal to 38 degrees. So that's helpful because now I can do something with that. I can go back to my original equation. 3y plus 28 is equal to x. So let's sub in. Now we know y is equal to 38 degrees. So I'm just doing a substitution. 3 times 38 is 114. 114 plus 28 is equal to x. And x is equal to 142. So there you have it. And also please make sure you're writing them on the right line. First time I tried this out, I put them on the lines backwards, which is such a silly mistake. So just make sure that you have them in the right place. So here we go. I have y equals 38 degrees and x equals 42 degrees. So I put them in the correct line. So again, this angle required, this problem, you had to know that vertical angles were equal to each other and also recognize the other side, which ones were also congruent, and a supplemental relationship. Let's look at this one. It's an EE problem, and I did put my final answer here. It's a 2-point problem, but most kids got less than half the points again. So we're going to try and figure out where did the student make the error in their work. So what I find is I try to do the work with the student to figure out what happened and where there may have been a difference. Alright, so I'm just going to distribute. Negative 3/4 times negative 8 is negative 24 over 4x plus 60 over 4 is equal to 8x plus 24. So far, a big difference, I still have fractions. This one doesn't, so I'm going to keep going. Negative 24 over 4 is negative 6x plus 15 is equal to 8x plus 24. So far, these are absolutely equal. We're good to go. All right, so it's not step 1. Step 1 is correct. So let's keep going on and figure out what they did in step 2. So in step 2, it looks like we moved the 6x on the first side. We added 6x on the second side, and so I'm getting 15 is equal to 14x plus 24. So let's check. 15 is equal, oh, there it is. Here's the mistake. How did they get 2x? So they definitely did 8x plus 6x. So what happened here? It looks like what they probably did was they subtracted 8x minus 6x to get 2x. So there's the error. So I'm going to put my answer here. The error is in the second step. (8x plus 6x is not equal to 2x. They accidentally subtracted, and I'll just show 8x minus 6x is equal to 2x. All right, so there's their error. I found the first one, and now I need to find the correct value of x. So I'm going to continue on with my work. I'm going to draw a little arrow so you can follow along. So 15 is equal to 14x plus 24. Let's create a zero pair. 14x is equal to negative 9, and then divide both sides by 14. x is equal to negative 9 over 14. And there's my final answer. All right, so again, you needed both points to be true. You needed to, one, identify the correct error in step 2 and explain it. So it was not just saying which step, because anyone could guess. You could have just said step 2, but you needed a valid reasoning that shows you understand what the error is. So a lot of times students will say where it is, but they won't explain it. And then just showing that you know how to continue to solve for x. And notice how I continued by just showing my work and telling you where to continue so you can follow my train of thinking. That's what you want. You want your thinking visible on the page so that someone else can follow it along. Okay, here we have a function problem. This one's getting closer to at least half the point. So 0.84 out of 2 points. Two functions are represented. We have the first one here as an equation, and then we have the second one as a graph. And we want to know the difference in the rate of change. Okay, so we need to find, we have the rate here, y equals 35x. There's the rate. We need to find the rate on our graph. So we're going to find the unit rate. In other words, when x is 1, what is y? So that's all I'm looking for right here at this point. 150. With that, I can write this down as a rate problem. And this would be y is equal to 50x. So taking a look at that, what is the difference between A and B, function A and B? Function B has a rate of 50x, which is 15 greater than function A. 50x minus 35x. So I'm just going to do 50 minus 35 is equal to 15. That's it. That's all I really had to do to show the difference in rates. So you can jot this one down. Again, the trick to this one was identifying the unit rate. And I just find that I identify that point on my graph. Once I have that, I can figure out the constant rate of proportionality. In this case, it was 50x. Another thing you could do was use sum of the points. So let's say you didn't know that, and you picked this point over here, 200 over 4. You could have then simplified it to 50 over 1. So that would be another thing. You could take other points and then simplify it to find the rate when x is equal to 1. All right, let's go to, okay, here's 46. It's another 2-point problem. My final answer is going to be 5 gallons. Let's look through. This is a geometry problem. At the beach, a child uses a container in the shape of a cylinder. So that's going to be important to build a sand castle. The container has a height of 10, a diameter of 12, and there are 231 cubic inches in 1 gallon of sand. What is the approximate volume of sand in gallons of the container? Okay, so even if I didn't know my reference table, I know that when I'm finding volume, I use the area of the base times the height. So volume, my base is a circle, so its area formula, pi r squared times height. I know the height is 10 and my diameter is 12. Okay, so volume is equal to pi, my radius has to be 6 times 10. So look first, show that you know where the formula is. You can find it on your reference table. Second, substitute them in. And now we're going to solve pi times 36 times 10. Let's rewrite that. 360 pi is the volume. And again, we're going to, instead of just leaving my number this way, I'm going to use my pi symbol. So 360 pi, my volume is equal to 1130.97 inches cubed. Now that's the volume, but now I want the volume in gallons. So I know that in 1 gallon there are 231 cubic inches. So I'm going to convert to gallons. Okay, and I get 4.895. And they said I can round to the nearest gallon, so I'm going to round to the nearest whole number and round this up to 5 gallons. Okay, there's my answer. First you find the volume of the cylinder, and then I converted it to gallons using the information. 2 more problems to go. Now we want to determine the solution to this equation. Let's solve for x. This one's also pretty low, so 0.47 out of 2 points. And notice that I have numbers in fractional form and as decimals. So I'm going to make a decision here and think for myself, which would I rather work with? Decimals or fractions? I'd rather work with all decimals because I have a calculator. It's easier for me. You have choice. And I'm gonna turn this to negative 0.5. And that's just because it's gonna make it easier for me when I'm converting units. At some point, I'm gonna have to change one of those around. So why not do it here? All right, so I'm going to start with my expression on the left, and I'm going to distribute. So leave this alone. Negative a half times x is negative 0.5x, and negative 0.5 times 4 would just be negative 2. And again, if you're never sure, like if you have to do this, sometimes you can do it. And I just know this was a negative sign, so there you go, negative 2. Now I want to combine like terms, so I'm going to look on the left first. I like to put these closer to each other. And I do this even with my 6th graders, so that it's easier for me to just combine like terms. 3.2 minus 2 is just 1.2. And I'll do the same thing on my other side. Do I have any like terms? Yes. And notice I'm highlighting that negative in the 5/2. So 4.8x minus 5.2x plus 2. So I'm going to combine these together, and that's going to be negative 0.4x. Okay, so far so good. Now we just have to get all the x's to one side. So I am going to, let's turn this to a 0 pair. And we'll do the same thing on this side. So I have 1.2 minus 0.1x is equal to 2. Let's subtract. Let's make this into a 0 pair. So negative 0.1x is equal to 0.8. All right, and now the last part, I'm going to divide. And I get x is equal to -8. Okay, now we're up to the very last problem. It's our 3-point problem. And notice the average was 0.69 points out of 3, so less than a third a point. So this one was a little challenging for a lot of students. So let's figure out why. 3 equations are listed below. One is identify one linear equation and one nonlinear equation from the list and state the reason why. How do you know? So the first one I'm going to do is I'm going to look for linear. I want to write these in y equals mx plus b form. So my first one, I'm going to distribute the x and I get y is equal to 3x squared plus 2x. So I already know this is nonlinear because my x over here is to the second power. That's nonlinear. If my x is to the first power, it would be linear, but this makes it nonlinear. So I'm gonna jot this down. And my reasoning, let's capitalize this. Dx to the second power which would not create a constant difference. The y values would grow exponentially. So, all right, what do I even mean by that? This is what I mean. I'm going to show if I made a little table. So here's x, here's y. When x is 1, when x is 2, when x is 3. Watch how fast the x is going to grow in that equation. So when x is 1, I'm going to get 3 times 1 squared plus 2 times 1. Okay. 3 times 1 squared is still 3 plus 2, so I get 5. So y is 5. Look what happens when x equals 2. 3 times 2 to the second power plus 2 times 2. So now I get 3 times 4, which is 12, plus 4 is 16. So far it looks okay. It jumped from, my y's jumped from 5 to 16. Could still, what's the difference between these? It's a difference of 11. Could be linear. But what happens when x is 3? 3 times 3 squared plus 2 times 3. 3 squared is 9. 9 times 3 is 27. So now I have 27 plus 6. So now it jumped all the way to 33. Look at what that type of jump. So it didn't jump up just by 11. It jumped up even way more than that. 27 plus 6 is 33. So it went up by how much? By 17. So this is not constant. That's not making a straight line. You're not getting a constant rate the way you would when it was linear. So let's look at the other two. The other two equations, this is linear. Y equals 1/3 x plus 2. That would create a line. And so would the next one. Y equals -3x plus 2. Those are both linear. My x is to the first power. And I'm going to show you the constant difference in a second. So y equals 1/3 x plus 2 and y equals -3x plus 2 are linear. Both are in slope-intercept form. And x to the first power. they have constant rates of 1/3 and -3. I'm going to use the word respectively. And that doesn't sound like a word an 8th grader would use. Both have constant rates, comma, 1/3 and 3. Okay, so just so you can see the difference with constant rate, let's think about this first one. I'm going to make a little page. So -3x plus 2, I'm going to add a page. And let's look what the constant difference is here. So 1, 2, 3. So when x is 1, I have -3 times 1 plus 2. So -3 plus 2 is -1. When x is 2, I get -3 times 2 plus 2. -6 plus 2 is -4. Okay. So far my difference, I have a difference of 3 here between these two numbers. -3 times 3 plus 2. -3 times 3 is 9. 9 plus 2 is -7. So I still have a difference of 3. Even if I go to the next number 4, -3 times 4 plus 2, I'm still going to get that difference of 3. -12 plus 2 is -10. So here you can see the constant difference. Each time my numbers are going down 3, down 3, down 3, down 3. I can literally see it over here, and you can see the constant difference happening here. My numbers are changing by 3. They're going down by 3. Whereas in my other example, my difference were changing in other numbers. If I had gone to the next one, which is 4, when x is 4, so 4 to the second power plus 2 times 4. Okay, 3 times 16 is 48. 48 plus 8 is 56. So it's jumping up even again. So now it's jumped up by 23. So my numbers, they're not changing by a constant rate. So I'm going to stop there. I really want to talk about second differences, but that is something you'll learn in algebra. But this is the end of the 8th grade exam. So big takeaways, just make sure that 1, you are showing your thinking and you're using all the information from the school year to really help you to study. And if there was something here where you had a different answer, please try and think what is the difference in the work that gave you a different answer. If you had a different strategy and the same answer, as long as it's mathematically valid, that is fine. There are multiple ways to get to the same answer. But that's it for now. Good luck on your state test next week. If you have questions, put them into the chat, put them into the comments. If you have other strategies, share them with one another, and keep following us. If you're new to the channel, follow us at Math Mini Lessons. If you're a returner, welcome back, and we will see you next year. Take care.